Welcome back to another installment of SGD Programming. In the last video you added objects to the game, but there was no interactivity. In this video you'll change that by adding movement. During the last video you may have noticed the slides follow a pattern. First is the class to which you'll add the world, then the type of code to be added, and finally the code itself. Because of this, I'll go straight into explaining the code from now on. In this case, you'll add a boolean. This will be used to determine if an enemy is targeted by a torpedo. In the act method, you'll add three method calls: turn at edge, random turn, and move. Now, add method turn at edge, which will make the enemy turn if it hits the edge of the screen. Random turn causes the enemy to turn at random every act call. This will make enemy movements unpredictable, as they can turn anywhere between 45 degrees to the left or 45 degrees to the right. Now, save and close the enemy class. Open up the torpedo class and add the import statements outside the class declaration. List allows you to make lists of different types, while math adds useful mathematical methods. The instance variables set the speed if the torpedo is tracking an enemy and which enemy the torpedo is tracking. Note the use of static final, which prevents any programmatic changes to be made to the variable. The act method consists of two method calls which you'll add shortly hereafter. The target enemy method first checks to see if the torpedo is not tracking the enemy. If it isn't, it initializes smallest distance and a list of enemies. Iterating through the enemy list, the program then determines if an enemy is not targeted before calculating its distance using math methods. If you know your math, you'll notice how this distance is calculated. Depending on which enemy is closest to the torpedo, the enemy's is-targeted boolean is set to true, and the torpedo's is-tracking boolean is set to true as well, preventing the code from being run by this particular torpedo object. Attack enemy makes the torpedo move towards its enemy, depending on where the torpedo and its enemy are. It then uses set location and the variable torp speed to move it. The code continues on the next slide, so be sure to type everything together. Save and close the torpedo class and open the player class. These variables set a time limit on how fast the player can fire a torpedo. The act method only contains one method call, check key press, which, as shown right here, uses the isKeyDown method to make the player turn, move, and fire a torpedo. However, besides having to meet the condition of space key press, a torpedo can only be fired if there are more than 0 enemies on screen and if there are fewer torpedoes than enemies. In the fire torpedo method, we check if the player can fire a torpedo by comparing last fired and fire rate. If they are the same, a torpedo is added, and if not, the counter is incremented. Now, save and close the player class, then save and compile your scenario. When you run it, you have moving enemies, and you can move your ship around and fire torpedoes. Of course, we need collision detection to actually destroy the planets, enemies, and even the player. So, join me in the next video as I explain how to do that. Thank you for watching, and until next time.